All right, we are now in Chapter 7 still, Lesson 5. And the title of this chapter is, this section, is Solving Two-Step Equations Using the Distributive Property. Now, I'm going to go ahead and start with these notes on page 550 with our examples. At the top of 550, we have this explanation up here about an equation and the form it comes in. I'm not going to lie to you, most of you probably won't understand this, and it will really only make sense as we start doing the work. So I'm going to go ahead and explain to you just how to solve these types of problems. The good news is that it's exactly the same of what we've been doing for the last 3 or 4 sections. And really there is no bad news I can think of, so let's just go ahead and just jump right into it. Get your paper, get your notes ready. I guarantee you're not going to have enough room on the side or the margin to do all this work. So you should be doing this on a separate sheet of either regular paper, graph paper, notebook paper, whatever you want, as long as you can turn it in and show to me that you're doing work. Now, let's begin. First step whenever we're solving equations is to always rewrite the equation nice and big so we have enough space to actually work and see what's going on. Just like in the previous lesson, we're going to make a t-chart that talks about what's happening to our variable. In this case, our variable is the letter x. Now let's talk about what's happening to x. Well, x is being added by 5, and it's being multiplied on the outside by 3. And when I say outside, I mean the outside of these parentheses. Since the addition of 5 is happening in parentheses, I'm going to make a little note and put parentheses around that 5. You're going to see why I did that in just a second. Now, here's what makes this whole lesson different is the fact that we're even dealing with numbers or variables in parentheses. This process is still the same. We're going to write down the opposite. Opposite of multiplying is division, and the opposite of adding is subtraction. Now, when you have parentheses involved, here's the difference. You want to get rid of whatever's outside of the parentheses. So in this example, I want to get rid of this number 3. Well, according to these steps down here that I'm going to follow, to get rid of a 3, I'm going to have to divide by 3. So I'll make a fraction bar on the left-hand side of my equal sign and on the right, and divide both things by 3. So on the left, if I have something, no matter what it is, a variable, a number, a bunch of variables, a bunch of numbers, no matter what it is here, if I'm multiplying it times a number and dividing it by that same number, I end up back with what I started. So these 3's cancel out. They cancel each other out, and they leave me with whatever was left over. Here, I have some division, 45 divided by 3. I know my basic math skills tell me that 45 divided by 3 is 15. So now that I got rid of the parentheses, I can do my last step, which is to subtract 5. Now, I have parentheses here, but if you notice, the parentheses aren't really separating anything. So I can pretty much just get rid of them now, because there's nothing in front anymore or nothing behind them after. And I'll continue my work. To get rid of this plus 5, I'm now going to subtract 5. Notice that I've never added or subtracted anything underneath my x. It continues to keep dropping down as I solve my equation. If I have 5 and I take away 5, or plus 5 minus 5, that leaves me with nothing, so I write nothing. My equal sign drops down, and now I just have 15 minus 5, which is 10. So we suspect that x equals 10, but you guessed it, we need to check our work. So I'll go ahead and do that. We're going to check. And you guys will be doing this also in order to make sure you get the right answer. When you're doing these checks on your own, if you don't get the right answer, come and talk to me and maybe we can figure out what went wrong. Quite often it's just a really simple basic math mistake. So my original equation was 3 times parentheses x plus 5, close parentheses, equals 45. Wherever I see an x, I'm going to plug in a 10. So it becomes 3 times 10 plus 5, we hope equals 45. Using PEMDAS, I do parentheses first. I have addition, so 10 plus 5 is 15 times 3. Now I have multiplication left over, 3 times 15. That is 45. That also equals the answer on the right-hand side. So since these two things are equal, I know this answer is correct. X equals 10. Let me make it a little better. There we go. X equals 10. If you have any questions, please remember to write your questions on the side over here in the notes section. Here's a little note for you. Remember to plug your solution back into the original equation to see if it makes a true statement. And that's exactly what the checks have been doing. So hopefully you've been doing that. Let's go ahead and continue on with the next example. I'll clear my screen out. And notice that they do ask us to use a model, but I'll show you how to do that at a later time in class. So for now, let's just worry about showing the work and working algebraically. Next example number 2. Same exact process, get another piece of, well, not another piece of paper, but make sure you have space to do the work for this problem. Whether it be another sheet of paper or not, I don't care. But it should not all be scrunched in on the margin because I don't see how that would work. Whoops, I got confused here with my pen. All right, let's go ahead and move this. So, repeat the process over and over and over again. Write your equation. 5 times n minus 2 equals negative 30. Make a t-chart. My variable is n, so I'm going to call my t-chart n. What do I see happening? I see it's being subtracted by 2, and that's in parentheses. And then it's being multiplied times 5. What are the opposites of these two operations? Well, the opposite of subtracting is going to be to add 2, and the opposite of multiplying is going to be divide by 5 in this case. These two steps I'm going to use to solve my problem. All right, so let's get rid of what's outside the parentheses, which is this times 5. Well, what undoes multiplying by 5? According to this, dividing by 5. So I'll use fraction bars to show division. I'm dividing both sides by 5. My equal sign will go ahead and drop down. If I have something that I'm multiplying times 5 and then divided by 5, that cancels out, and I'm left with whatever was there before. I can go ahead and drop the parentheses because they're not separating me from anything. Negative 30 divided by positive 5. If I'm dividing and I have different signs, a negative and a positive, I'm going to have a negative answer. 30 divided by 5 is 6. Now I continue with my next step. That's going to be to add 2. I add 2 to the left and add 2 to the right-hand side. Notice I've never added or subtracted anything underneath my variable. It continues to drop on down through this problem-solving process. If I owed you $2 and I paid you $2, I now owe you nothing. So that's exactly what I write, nothing. Equal sign drops down again. If I owed you $6 and I paid you $2, I still owe you $4, negative 4. Let's go ahead and check our work, everyone's favorite part. And we have 5 times n minus 2. We hope equals negative 30. We think that n is negative 4. So wherever I see a negative 4, I'll plug it into my equation. Using PEMDAS, negative 4 minus 2 will come first. If I'm at negative 4 and I go to the left or in the minus direction 2 more spaces, I end up at negative 6. Using multiplication, 5 times 6 is 30. A positive times a negative is a negative. And negative 30 does equal negative 30. So this is a true statement, which means my solution is the correct one. Any questions about what's happening in example 2, please go ahead and write it on the side so I can address it in class. If you have no questions, or if you're pretty confident that you know what's going on, go ahead now and do the got it's A, B, and C. Just solve the equation using the 3-column way I showed you. I should see the problem in all the steps, I should see your t-chart in the middle, and I should see your check. If your check works out, then your answer should work out. It only makes sense. And I will see you now in the next video for the next page. Good luck.